way I thought I could do that, just purely algebraically.
So you originally rewrote the second part in this way?
Yes.
Okay. Well, so this is totally legitimate, absolutely legitimate, that this is equal to the original e to the x plus 1 over e to the x. And so at this point, you're still not quite ready to integrate, so,
Right.
but from here, what did you do after that?
Just then one of the terms falls away because it becomes e to the 0, so it's 1. So
Right.
it becomes the 1, and then you get the final answer doesn't have to, you don't have to distribute that -1, it already comes out in the wash, and it just, does that make sense?
Not exactly. Can
Sorry.
you walk us through what you're talking about?
Could you just look at this, because this is the same problem on assignment 10.
Okay.
So that ends up being that.
Mm-hmm.
Then it's becoming this. So see how the signs are
Yep.
similar to that. So is that practical or?
Okay, so let me comment on, so I think what you're looking at. Tell me your name? Mark, thanks Mark. Okay, so Mark's suggestion is, well, once we have e to the negative x plus 1, if we look at then the integral of e to the negative x plus 1 dx, we can, so what I suggested here is let's do a u substitution. Let's make this change, let's let u be equal to negative x. So what I want to do is, and I'm going to make this observation so that we actually don't ever have to do that u substitution again. Let me observe the following. If I strictly have the integral of e to the negative x dx, so that's all I have. I don't have the plus 1 part in here. If I just have the integral of e to the negative x dx, and I do a u substitution, and I let u be equal to negative x, then my derivative, du over dx, is -1. And so dx is du over -1. And that can be written as dx is equal to -1 times du. So now when I go back into my integral, I have the integral of e to the u. My dx is -1 times du. I can pull that -1 to the front. And so I have -1 times the integral of e to the u du. All right, so I've changed everything in terms of u's. And now I can take my antiderivative. The antiderivative of e to the u is just e to the u. So I have -1 e to the u plus c. And so when I turn this back into my x values, I end up with a negative e to the negative x plus c. So think about what just happened here. The only thing that really changed from the antiderivative of e to the x versus e to the negative x was that I had this extra constant multiplied out in the front. So in that case, so the moral of this story is that my antiderivative of e to the negative x is negative e to the x. So if I go back over here to this guy and think, okay, if I already know what the antiderivative of e to the negative x is, then I can say, okay, this is equal to negative e to the negative x plus c. And so if I happen to know that shortcut ahead of time without doing the middle u substitution that we did here, if I happen to know that the antiderivative of e to the negative x is negative e to the negative x, I can immediately use that antiderivative. In that case, I end up with negative e to the negative x plus some constant. And that is also a legitimate final answer for this problem. Are there any questions about that?
So the number that you pull out in front of the integral, so you pulled out the 1 in front. So say that 1 was like a 100, is it just going to stay there? Like at the end of the answer, it's just going to be say like -100 e to the.
Why don't we change that to 100 and see what happens? So instead of the -1 up here, if we change that to a positive 100. to the 100x dx. I do my u substitution. Let u be equal to 100x. My derivative, du over dx, will be 100, which means that dx is du over 100. Okay, so I go back over here to my integral, and I have the integral of e to the u, and my dx is du over 100. And so when I pull that out in the front, because that 100 is in the denominator, it's not like -1 where it doesn't matter whether it's on the top or the bottom. I need to make sure that 100 stays in the denominator. So I have 1 over 100 e to the u, or integral of e to the u du. And so in the end, I've got 1 over 100 e to the u plus c, took my antiderivative, plug back in my x. So I have 1 over 100 e to the 100x plus c. And so you can probably see the pattern that's going to happen here is that if you have e to a number times x, your antiderivative is going to be 1 over that number times e to whatever times x. And that's going to work out 100% of the time that you have a power that looks like a number times x. All right. Does that answer your question? Mark, is that right? Mike? Thanks. Thanks. Okay. All right. So, are there questions about this idea? Yes.
I just thought it was easier, like from that step, to just separate the integrals.
This one right here?
Yeah, put the,
Yeah, absolutely. So another option here is to say, okay, I can take this guy and write it as the integral of 1 dx plus the integral of e to the minus x dx. The first antiderivative
Go
is
to
easy.
x.
That's just x, and then this guy, you can either do a u substitution or use this pattern that we just talked about right here.
I just thought it just erased all them, a few of them steps that you have to do the other way.
Yep, absolutely. And so again, there's going to be 50 different ways to work these. And so I want to encourage you guys, if I do write one particular way of doing it up on the board, if you suggest other ones, please do so, because other people in the class may be thinking exactly the same way you are. Okay. All right. Are there other questions about this particular problem? Aaron, does this answer your question?
Yeah, definitely.
Any more?
Yeah.